x to the third power. At 1, the y value is 1. At 2, the y value is 8. Try to be a little bit precise, because that helps you to find the intersections or whatever. X equal 2, that's a vertical line, right? And then if you know at x equal 2, this y value is 2 to the third power, which is 8. So they will intersect right here. This is the line. What is the base? We're looking at that is the region. They say the cross section perpendicular to the x-axis. If they say perpendicular to the x, that means you have vertical slides. If it's perpendicular to the y, you have horizontal slides. And then, no, here. Our question is perpendicular to the x-axis, so we are okay. Everything becomes of x. We need the bounds for x. We need the top minus bottom for x. When they say the cross section is a semicircle, does anybody remember the formula for that one? For those few who were here, what's the semicircle cross section formula? 1/2 pi s over 2 square, correct? I recommend you write that down on the paper, s over 2, because s is the diameter, right? Square, or let's another one, pi over 8 s squared. That's coming from 1/2 times 1 over 4 by factoring out the 1/2 square, right? What is s? S is top minus bottom in this case, which is what? What's s? Yes. Oh, no, not minus 2. Wait. Top is x cubed minus 0. Yeah. Top minus bottom, right? It's x cubed minus 0. Do you have to write minus 0? You don't have to. But again, I recommend it because what if you are not bounded by the by x, y equals 0? What if you're bounded by y equals 1? You need to do that top minus bottom all the time. Okay. So the antiderivative is super simple. We just need to use that. I like this one better. It's easy to compute. So the volume is pi over 8. What are the bounds? 0 to 2. S squared. So x is x to the third power. If I square it, is x to the 6th power dx. I'm just going to square it anyway because you're supposed to do antiderivative for a question like this. If you want to do safe stop, we also talked about safe stop last class. The antiderivative for x to the 6 is 1 over 7. X to the 7, you can evaluate that from 0 to 2 without doing anything with a pi over 8 and 1 over 7 because they are constant multipliers. You can just evaluate this part, right? So the safe stop will look like pi over 7 times a, 56, 2 to the 5th power, which 7th power, sorry, which you don't need to compute. This is called safe stop, minus 0 to the 7th power, which is 0. So I'm just say this is it. That's pretty easy to do if it's perpendicular to the x. I want to make a mark. This is the part where people get confused. What if I change this question? It's still the same curve, still the same bound, still the same region, but the cross section, instead of perpendicular to x-axis, we want perpendicular to the y-axis as semicircle. Okay, so which that means is, oh, I can't erase this. If I want a perpendicular to the y-axis as my semicircle, that's those semicircles on top of this, right? So they are horizontal slides if it's perpendicular to the y. And then if you do that horizontal slides, you need the y value for the bounds. You also need the y equation with respect to dy, right? So what are the y bounds if I want perpendicular to y? No, wait. The bounds first. What's the bound for y? Are you guys with me? 0 to 8, right? This is the y value 0. This is the y value 8. Those are the bounds for the y value. Are we okay so far? Everything is still the same. We're not changing this. We're not changing this, but we are changing the integrand. We also need to know what's the S if I want to do horizontal slides. How do we find S? Right minus left. Yeah. Top. Well, if you do this way, it's top minus bottom, but same thing as right minus left. Correct. What is right minus left in our case? It needs to be in terms of y. So first of all, this gotta solve in terms of x equal. So cube root, right? Cube root of y is equal to x. Is that making sense? So that is your cube root function. What is right minus left in our case? The right is what? 2. Subtract the left, which is the cube root of y. That is the new S if I want to do perpendicular to the y. So I'm telling you, this is the kind of question you're going to see. Like one question, they can ask you to do one way and then the other way totally around. So that can be very easy to make mistakes. So you need to understand what is a horizontal slice, what is a vertical slice. Because today we're going to make this even worse by doing this in washer. So now we apply to our formulas, pi over a s squared. This will be it. I'm not going to solve it because we already did it with dy. Okay, just to show you what they look like. And then again, for those of you who weren't here on Friday, you need to understand what's a cross section. Cross section means that you just cut your shape into those slices. Each slice look like whatever cross section it is. Like for example, like apples or things. You cut them and they look like those slices, right? So that's what that is. Now today, when we do this in a washer, our cross section is going to be a circle. That's even weird. Okay, so now back to our notes. I'm going to use some tool to help you understand 3D. Because again, it's very hard to rotate things in your head. And unfortunately today, the region that we got have to be revolved around some kind of axis. So you guys play basketball, right? Maybe, or soccer players. Don't you spin the ball somehow, right? You do? Okay. That's called a revolution, solid of revolution, because it's spinning around. Like if I'm trying to spin the basketball this way, it's just going to spin that way. Or it can spin like this way. That I don't know how that works. But anyway, we have a vertical revolution. We also have a horizontal revolution. So like imagine today what we're going to do is we're going to revolve some kind of region around some kind of axis. It's called the axis of revolution. So it's like if I'm using basketball, this is my finger, I guess. That's the axis of revolution right there. And you will spin, 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 spin. And then it will create a volume of shape. Some of my BC kids said, you can imagine everything Dixon washer as a vase. Like things you can put flowers inside, right? And then sometimes the vase is like all full. There's no holes inside. Sometimes there's holes inside. You can put flowers inside. I mean, everything is like 3D revolution shape. So that's called a Dixon washer. Now I'm gonna show you the actual 3D version. This is a disc. You can imagine apples. What else? Oranges. What else look like this? Basketballs, soccer balls. We want to find the volume of this. But what does this look like in 2D? It's going to look like this before you start revolution, before you start revolving it, which I also have a tool to show you. Okay, so imagine this is what I'm giving you. And it's going to tell you we're going to revolve this about the x-axis or the y-axis, whatever. So I'm giving you this, but in your mind, you need to visualize this. That's what's happening. And how does that work? Because this can open, right? This is how they revolve. They will go around the x-axis in 360 degrees to create this. That's what's happening. All right, so that is called the solid of revolution. Now, when you do this, if I start, can't see. if I start revolving, what is this cross section look like? That's exactly circle. So you can just imagine lots of circle inside. If I cut this way, right, horizontal, vertical, it's going to be a whole bunch of circles, and they are cross section of circles. So that's why the formula here is pi sum r squared, because all the cross sections are circles. Remember the cross section, the inside is just the area of the cross section, right? So the area of cross section is pi r squared. So that is the formula come from. We still have vertical slice and horizontal slice. If you have a horizontal revolution, which means horizontal axis of revolution, which means you are revolving about this way. This is the confusing part, okay? If I have a horizontal axis of revolution, you are actually rotating vertically. So it's kind of like spinning this way about the horizontal axis. So that's a vertical slice, which everything is in terms of x, like r of x, d of x, a and b are x. And if you have a vertical axis of revolution, so this is how like people spinning the basketballs. Usually it was spinning vertically, vertical axis of revolution. So therefore it's a horizontal slice. It's kind of like this way. Okay? If I have a vertical axis of revolution, it will be a horizontal slice. And then if it's vertical, what is r? R is the radius of our cross section. And then here is the cross section. Well, this is the cross section before I start rotating. So the r is basically top minus bottom. Same thing. We've been doing that all unit long, not changing. So here r will be created by top minus bottom. And if it's horizontal, they'll be right minus left. So that's, again, the same thing over again, right? What else? So now we pretty much do this problem, finding the actual volume of the disk. Now the reason why they call it this is because it's going to create like a ball with no holes inside. So if there's a holes inside, we're going to call them washer instead. So like if you can imagine avocado, banana. If I try to rotate a banana, the avocado is actually a pretty good thing to think. There's a holes inside. That's not a disk. The things that has to be like no holes inside will be the washer. I mean the disk. Okay, so it says find the volume of the solid region bounded by this graph. They give it to you in the x-axis. So here I'm going to show it again. Here's the region. What we're going to do is we're going to rotate this in our head. So kind of like spinning this, right? So what happened when you spin this? I actually drew the 3D. Where's my 3D picture? Oh, wait, right there. I kind of drew the 3D version of it. Once it's, you gotta visualize this. I'm not asking you to draw 3D on test. I mean, unless you are a really, really good drawer. But you gotta visualize this. Okay, that's how they spin. And when that happens, they creating those discs right there when they revolving, and that's gonna be the cross section. Okay, so the first thing we need to decide is this is a disk, and then our volume is gonna be pi, always pi something r squared. Without a pi, you're doing a cross. If you have some just like r squared, then that's just a cross section of squares. That's not circle, right? So you have to have a pi, and we have to have a bounds. What is the bound for this problem? What are the bounds? 0 to pi, right? Now, what is s in our case? That's our radius, which is the top minus bottom. You can use r all the time today because it's pi r squared all the time. So you are allowed to write big R. You can write r of x if you want to. What is our big R? The big R is the top, which is the square root of sine x, minus the bottom, which is 0, right? So that's our R. I'm doing pi r squared. So to make our integration easier, R is this. We don't have to have -0. If I square that, you're going to get just sine x. And then we're going to integrate that. Okay. What's the antiderivative for sine x? Hello, everybody. What's antiderivative for sine x? Negative cosine. So I'm going to put negative outside of pi. This is easier to evaluate. We are evaluating from 0 to pi. Cosine pi, again, everything you got is supposed to be a positive number. Okay, so we got a negative pi there. Cosine pi happened to be -1. F of b subtract f of a. Cosine 0 is 1. What's the final answer? Final 2 pi? Yeah. That's it. This first question is not that hard. I'm trying to give you the easy one first. And I also want to show you this really cool animation. You still can see 3D. I have a lot of people telling me they don't understand 3D whatsoever. If that's you, I have another thing to show you. Hold on. But this tool, it's great. It's just not 100% great. This is the 2D version, right? So here, you can kind of see from all angles how they become a ball. Anyway, like a real basketball, right? So that's how it works. Okay. Now we can try to figure out how to do the rest. And then you got to decide, is this a vertical slice or horizontal slice? So next, we're going to draw a picture first. What does x equal y squared look like? It's a quadratic open to the right, right? So that's this way. Those basic ones you need to know what they look like, because I usually don't give you the graph for the basic, ones. So we have a volume. We have a volume and the solid generated by this x equal y square curve, and then x equals 0, which is the which way? What's x equals 0 look like? No, x equals 0. X equals 0. X is vertical. Yeah, if you mess that up, then everything's gonna go wrong. X equals 0 should look like y-axis, right? What else? Y equals 0. And then y equal 1. Oh, wow. Do you know what part are they even looking for? The region. Which part should I shade? Do you know? Bounded by y squared, x equals 0, y equals 0, and y equals 1. Which part am I looking at? The tiny that. You gotta understand which part I'm looking at, right? So this is the one right there. Try to highlight it yellow. Okay, I have a blow up version, but I didn't. I kind of drew the reflection too. I will show you the blow up version very quick. This is the part right there. Okay, so now it says find the volume bounded by this, this, and this, and then we're gonna rotate this, revolving this about the y-axis. That's kind of like how you spin the basketball. I'm gonna rotate this whole yellow region about the y-axis. So you can imagine something like a tornado, right? Starting small and then getting bigger, 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 bigger that way. And I actually drew a 3D version for you. Here it is. This is what it's gonna look like right there once you 3D it. So you gotta visualize, 3D. So here I revolving by the y, and it looks like a tornado-ish or a bell, whatever, or cone if you want. It looks like very much like a cone, and that's the shape. Okay, so first of all, we gotta decide. When I do that, this whole thing has no gap, so that's a disk. Again, it's a disk. And then what kind of slice is this? We have to decide. wait, hold on. How do you spin? Yeah, there you go. You just need to think, how do you spin the thing? We are spinning this horizontally, yes. So that is a horizontal slice. If it's horizontal slice, we need top minus bottom. So if you cannot tell what is top minus bottom, I'm going to use the blow up version for you. It's kind of like right minus left right here, right? It is right minus left or top minus bottom if you do this way, which means it's the curve minus the y-axis. Yeah. What is the curve? That's our r. Who minus who? Y square, that's the right, minus the left, which is 0. Is everybody okay so far? The r, right? That's the radius. Now, what's the bounds for this? Again, don't forget pi. What are the bounds? We need the y bounds. What are those? 0 to 1. Yeah, it is 1, right? 0 to 1. Y square, I mean r square. So your r is y squared, which means we're going to have y to the 4th power dy. Again, this is one. It's very, very easy to integrate. I'm going to do the integration because you need to know how to integrate the very, very basic thing. This is pi times 1 over 5, y to the 5th power, evaluate from 1 to 0. So the answer is just pi over 5. It's nothing else but pi over 5, right? So again, horizontal is a little bit weird. You just have to think right minus left. All the equation has to be in terms of y, which you already have. Now, sometimes they can make this even harder by not giving you the equation in terms of, x. You're gonna solve it. All right, so now we're gonna get to washer. Washer has holes. So again, you can imagine the vase. We're gonna have the inside is like big holes. You can put things inside, like the avocado, right? The seed is inside. We do not want the seed. We want just that, okay? So here is what the washer look like, and then banana. Oh, here it is. That's like a washer in 2D. This is like a washer in 2D, right? How do I find the volume for this guy? So again, we're gonna revolving them. If I revolving them, it's kind of like a donut almost, right? So how do I find the cross section? This is the cross section look like. How do I find the area of this cross section? How do we find the area of this cross section? Well, how do you find the area of this? Outside minus inside. Yeah, the big circle subtract the small circle. We don't want to eat the seed. We want to eat everything else, right? So that is the volume formula for washer. And how do you know you have a washer? As long as there is a gap within the region versus the axis of rotation. So let's say I have this region right here. I want to rotate either around the X or around the Y, doesn't matter. There's a gap between the region versus the axis of revolution. That's a washer because there's holes inside, okay? Now, I do not like the formula they told you in the thing because it is hard to compute them separately. I write them together. So volume, make sure you write this down in your notes. Either A to B or C to D, doesn't matter. Pi times the big R of x squared minus the small r of x squared. Some of you are falling asleep already. I don't know. I'm not sure how you do that in this very hard question lesson of the year. I don't know. How about making you stay after class if you want to stay sleeping? I'm sending my recording. Oh my gosh, everyone's gonna laughing at you. Miss Luz 4A is falling asleep during this washer. That is the formula I want you to use. What is big R? Hold on. I do this again. The big R will be your top minus bottom, same name. The small r, it depends, top minus bottom, but sometimes they will have like this kind of shape. So your top and bottom may be different. They can be either the axis of revolution versus the curve or the other way around. It just depends which part you don't want. Okay, so that is our big R. That was our small r. We always use top minus bottom, right minus left, no matter what. So write this down in your notes. Top minus bottom for big R and small r. That's the outer region. That's the inner region. Right minus left, the outer region. Right minus left, the inner region. And now we're gonna start working on washer. Okay, flip to the back side. Unfortunately, the grid I'm giving to you is too small. So I'm gonna try to blow up a little bit so you can see better. And I did draw a 3D figure for some of this. I can't draw all 3D. All right, so first question number 3. I'm gonna draw very big, okay? The square root of x, you guys know what that look like? What does it look like? That square root of 0 is 0. Square root of 1 is 1. Square root of 4, 1, 2, 3, 4 is 2. So that is the square root of x. Square root of x is concaving down, but x squared is concaving up. So x squared will be below square root between 0 and 1. That's something you probably need to know. This is x squared. So this solid is bounded by square root of x, and then the x squared, we're gonna revolving this about the x-axis. So first of all, I'm gonna show the region we want. That's the region bounded by those two curves. How we're gonna revolving this? It says revolving by x-axis. That way. So first of all, how does this mean? Spin, vertical or horizontal? Vertical. Yeah, that's number one thing you need to understand. This is a vertical revolution. Is this a disc washer? It is definitely a washer because there's a gap between the yellow part versus the axis of a revolution, right? So that is a washer. And I can even show you, I drew a 3D figure for this. I learned how to draw 3D today. When you're revolving this by the x-axis, it's kind of create a little bow-ish. That's my 3D figure, okay? Kind of like those bow for the pets, kind of like that. Has a circle here, circle here. Anyway, that's a 3D figure. I try my best to help you understand 3D. And then the holes are, inside. That's where the fluid goes. This is the outside. We want the yellow part. So here, I also blow this up a little bit. If it's a washer, we have two types of radius. A big R versus a small r. Now here's the part people don't understand. Okay, like you want to have the yellow part, right? So the big R is kind of like you want to eat the whole avocado, including the seed. And then the small r is going to be you're taking away the seed. So that's basically it, okay? So our big R, what do you think that is? Who minus who? The top is the square root of x minus the axis of revolution. You have to go all the way to the axis of revolution first. You want the whole thing first, okay? The whole fruit, we want to eat it. That's the square root of x, the minus 0. The small r is whatever part we don't want, right? So we want the yellow part. We don't want this holes inside. We want all of this to be gone. So which is the bottom curve to the x-axis. I recommend you draw those big R's and small r's on your picture because it helps you understand which one to subtract. Because I will always have people do curve minus curve for some reason, which is wrong. That's not big R minus small r. That's just wrong, okay? So our small r here is x squared, subtract 0. Once you have that, the rest is easy. What's the bounds? What are the bounds? 0 to 1, right. Volume equal pi, don't forget. 0 to 1. I'm just going to do r squared minus r squared. So if I want to square the r, in this case, will be just x. If I want to square the small r, it will be x to the 4th power. Because again, this kind of question is very likely on the test. I'm going to ask you to integrate it to find the answer. So if you want to make sure you simplify it before you can integrate, majority of them are power rules. That's pretty much it. We're going to do is just set up for the next 4 questions. I'm going to let you try one yourself later. Okay. Now, we're going to try one more, and then you can try the number 5. For number 4, it says write but do not evaluate, which means we don't care the answer. We just want to set up the integral. This graph, very likely I'm going to give it to you on the test because I'm not sure if you know what 3 minus y squared look like. Does anybody know? It's a parabola, but opening which way? Left, yes. What does 3 do? It moves 3 to the right. Yeah, it's like this. And then it moves, it's kind of like opening left. Again, I will try to give you all the graph that's really, really hard to think of. The ones you need to know how to do is like basic parent function graphs or linear functions. We have this region bounded by 3 minus y squared. Also, x equal 1. X equal 1 is the vertical line. Bounded by that, which means the area I will recommend you to shade or highlight is this, right? Okay, now here's the important part. What am I going to do with this guy? Revolving this region about the y-axis. So here is the y-axis. I'm going to draw the axis of revolution for you because it's easy to tell if this is a disk or washer. We're going to spin this one by the y-axis. Okay, 2 questions for you. Horizontal or vertical? Horizontal. Good. Horizontal rotation. Next question. Disk or washer? Uh-oh. Why? There's a gap right there. There's like a cylinder inside the ball. It's like a cylinder inside the ball. Yeah. See that? A cylinder inside the ball. There's a gap. So like now, what makes a disk? If the axis of revolution is exactly at x equal 1, that's a disk. Is that making sense? There's no gap. But the revolution versus the region, this is why I drew the revolution, you see? There's a big gap, and that will create a cylinder when you're rotating it. All right, so now we need, if it's a washer, we need 2 things. A big R versus a small r. Do you know what those are? Who minus who? 3 minus y squared minus 0, yes. And then you are allowed to write y of r here, and then r of y, that's what I meant. R of y, big R of y, and then small r of y, because all we need to do is just do the setups. If you don't want to do that, that's okay. Your big R of y is curve minus the axis of revolution, the whole thing, right? Which is 3 minus y squared minus 0. What is small r? Good, the cylinder inside, the holes. Yeah, it is right here. So that's why, again, try to draw them to help you understand which part we don't want, which part we do want. It is 1 minus 0. Now, if you wrote this as the notation, all you need to do on the setups is to try to figure out the rest. Do you know the bounds though? No, it's not always minus 0. That's a good question. It depends on the axis of revolution. Like if the axis of revolution is somewhere else, then this is somewhere else. Yeah. What are the bounds? Nope. How do we find the bounds? Anyone know? You can set the y. You can set these 2 equal to each other. Yes, yes, yes. 3 minus y squared must equal 1, right? They must intersect. What is the y value? It's not nice. Square root of 2 plus or minus. That is the bounds we need anyway, because they are the y values, right? It happen to be the y values. We need that. What's the inside? Now, if you already wrote this, then you don't need to write again. You can just do that on the AP test or Miss Lu's test. R of y square minus R of y square. The who? Yeah, that's it. Done. This is allowed as long as you define what's R of y, the big R of y, and the small R of y. As long as you define those, you're allowed to use those notation on the test. Okay. Now you do not want to do just like that. That doesn't make sense. You need to define R of y or R of x, right? It needs to look like that. So as long as you define them, you can use them all the time, which I recommend it. Anyway, especially on the FRQ. Okay, now I need you to do 5 by yourself. Try this out. Or like okay, so either it's the line to the curve or the curve to the line. It depends on which one is the top, which is the bottom. Draw this line first. Oh, so which region are you looking at? No, it's bounded by x squared and y equals 5. So the whole quadratic. So you know chart? Yeah. There you go. Yeah, that's the one. So now let's talk about who's the top? Look at this region. Which one's on top? Is it no, just look at the whole region. The top minus bottom. Asking about y equals 5. Yeah, 5. Yeah, if it's about y equals 5. Oh wait. Usually it's very good person, right? You don't have to y equals 5. Yes. But they gave us a horizontal axis. No, that's what I also thought. It's true. It's a vertical slide. Absolutely. No, the whole yes. On all the properties. Small part, did you get 5 Don't tell me so sad.
No horizontal.
On the axis, but vertical slides.
Is it plus or minus?
Tuesday or Monday? All right. See if you did this one right. Again, my picture may not be very good. So guys, listen, this one I am revolving by the y equal 5 line. So it happened to be a disk because there's no gap. And it's a vertical slice because we are revolving this vertically. Yeah. What's R? We just need 1 R if it's a disk. 5 minus x squared is the correct R. Oh, I should write R of x instead. If you don't like to use this notation, you can just write this inside the integrand. It's fine. So like if you don't want to write that, what's the bounds though? Anyone know? Oh, good. X squared equal 5. So x is plus minus square root of 5. Nice. Volume is pi from negative root 5 to root 5. For those of you who don't want to write R of x right there, you can just do, 5 minus x squared all the way square here. That's also allowed. Whether you put the equation here or not, that's up to you. Depends on how you feel comfortable with. Now, I will sometimes ask you to integrate this. If I do ask you to integrate this, you want to put the equation inside here, right? Otherwise, it's going to be too weird. You will FOIL this, and then you will do the integration. So that's not too bad, right? All right, number 6, find the volume of solid generated by, try to draw this. I'm gonna draw a little bit bigger because I don't like the grid. It's too small. I can't even read the grid. 1, 2, 3, 4, 5, 6. 6 minus x is a line going this way. Right there. And then y equals 0 is the line going this way. I need to use a different color. Y equals 4. Man, it's this 1, 2, 3, 4 line going this way. And x equals 0. That's this. Okay, do you know which region we're talking about? Which one's bounded by all of this? The trapezoid, right? Ah, good. All right, how do we want to rotate this thing? We want to revolve in this region about x equals 6 line. So again, draw the axis of rotation. X equals 6 is a vertical line at 6. This is the rotation. This way. Okay, now you gotta start to think. Disc or washer? Which one are you doing? Horizontal or vertical? A lot of things to think. Yeah, what do you think? Ah, very good. Because you want the yellow part. So you want to erase the white part. Yes. Well, we gotta make sure everything's in terms of what? You gotta solve this equation. Have we decided what is this, washer or disc? Okay, good. Horizontal or vertical? Horizontal or vertical? Horizontal. If it's horizontal, guys, we need everything in terms of y. This guy is not. So you gotta solve it. How do you do that? Subtract 6 on both sides, right? Y subtract 6 is negative x. How do you get x by itself? Negate both of them. We need the equation to be in terms of y, not in terms of x. That's the number one thing people don't do. So the line here is a negative y plus 6 line. How do I find the big R? What is big R, you think? From where to where? This is horizontal, so got to right minus left. What is right? What is left? 6 minus 0. Yes. Okay. What is the small r? Remember, we want the yellow part. So which part we don't want is this part, right? Don't want, right? So what is small r? 6 minus the curve. Agree? The inside, this part we don't want to eat. We want to take away the inside. Yeah. So that is 6 subtract the curve, which is this. Obviously, you can simplify that. That's just y, right? If you distribute the negative. So now, again, this is a very easy question. What are the bounds for this? We need the y value bounds. 0 to 4. Nice. Good job. Good job. Big R, if I square that, it will be 36. Small r, if I square that, will be y squared. So this will be easier to integrate if the question asks you to integrate. Are we okay? It takes a lot of practice to be good at this. I'm telling you, there's a lot of room for mistakes. Like this other part, people will not do right, or the dy becomes dx or whatever. Okay, we need a calculator. Grab one.
Yeah, you got it.
Thank you. Thanks. Clear memory, guys. Clear memory. I love this question. One question covers the entire unit. They are happen to be your very test question can be, you know, they are very, very similar. So again, when you have a calculator problem, make sure you clear memory, because all my other class already did this question. I don't want you to get their answers. I want you to use your own answers. First thing you do is graph them. Now I'm going to tell you TI calculator, guys, listen, TI calculator has a bug. They have no idea how to draw a natural log of x, but you need to know how to draw a natural log of x without calculator. What does the natural log of x look like? It's like a square root, but yeah, it's not, yeah, but it's just like that, right? So you need to know that, because look, this is what TI shows. It's so ugly. Hold on, let me draw the other one too. 2x minus 3 is so ugly, and they can't even find the intersect. This is what TI does. That's a bug. Technically, there is two intersections, but you cannot even see them unless you zoom in. So what I will suggest you, because you probably can't find this guy until you zoom in, okay? You can either change your window. The y value does not need to go from -10 to 10. It can just go from -5 to 5. You probably will see the intersection, I hope. No, never mind. How about -3 to 5? Ugh. Nope. Okay, never mind. What's a good window? I don't even know. Hold on. Let me think. How about zoom in? TI has just bad. Oh, there you go. Things about the natural log for some reason until you zoom in. I did zoom in instead. Might need to change the window a little bit slower. So, okay, here it is. Yeah, you gotta do something until you can see both intersections, okay? Otherwise, you probably won't find the bounds at all. This, we can call them the A value. This is gonna be called a B value. So some kind of trick I can show you. Let me go back to standard. You can like do zoom in by, I will probably like go down a little bit here and then do zoom in. That will work. You will see it. Or you can change your window for X and Y until you see the two intersections. Once you see the intersection, can you find them? Find them, guys. Crashed, clear memory. Oh, great, number one. They crash all the time. It's TI. Oh, you can use that a decimal on AP exam now. So if you feel like this is too hard, too much work, do decimals instead. How do we find intersections? Second trace number, which one? 5. Now move your cursor a little bit, okay, until you see those blinking things at you. If you don't see that, you can't find it. Press enter 3 times. 1, 2, 3. The first intersection I found is 0.0556. Did you find that? No? Yes, no? Second trace, number 5. Do I need to do it again? Move the cursor until you can see the blinking guy blinking at you right there. It has to be blinking. Press enter 3 times. It will stop blinking, maybe. That will be our A value. Huh? It dies all the time. Another calculator died. Okay, we're gonna wait until this stop dying. Okay, write down the A value. You need to write at least 3 decimal places. I usually write as many as I want. Do you remember how to store this? You guys remember how to store this? How do we store this? Clear first, right? Press X first because that is the intersection. And then we press store, right? Or store right there. Press alpha, either A or B, because you want to store to A and B, you're going to use them all the time. We have 2 intersections. You got to find A and then you got to find B. Is it late now? No. It's super dead. Find another intersection. Do the same thing. But you gotta move your cursor a little bit away from the first one, go to the second one right there, press enter 3 times. 1, 2. Oh gosh, I cannot do that. 1, 2, 3. The second one I found is about 1.7915 here. Also, I think you can. The window, by the way, I have is about negative 2.5, 2.5, and those. If you want to use my window, it works. The zone. Yeah, you have to zoom out. This is too much. You cannot see the
Exactly.
So I will zoom out first, and then zoom in again. Like here, I will zoom in, but I'll move down a little bit. Zoom in.
Oh.
Yeah.
And then alpha.
Yeah. Okay. All right, guys. Store this into B. That's our B value. See, and then we can set this up because we need to find. Right. Part A says find the area of R. How do we find area again? This is the first thing we learned. Top minus bottom, done. There's no pi, there's no R squared, there's nothing, right? Just top minus bottom. Which curve is on the top? I'm pretty sure the blue curve, which is the natural log, and then the linear is on the bottom. So if I want to find the area, the integral it will from A to B area. You don't even have to write the area. It's okay. Integral from A to B, top minus bottom. They did not define f and g, so you cannot use that. You can just write the equation. Okay, at natural log of x, I don't even distribute negative. I use parentheses all the time. dx. Do you know? Remember how to put this in the calculator? Which button do I use to calculate this? Alpha window number 4, right? And you will type like alpha A and alpha B in there. This is very, very useful on your AP test too, right? So you don't waste your time to like type A and B. Do you remember how to get this guy minus this guy? This is Y1, this is Y2. Where do I find that? Alpha trace, that's right. Number 1 for Y1, subtract alpha trace, number 2 for Y2, and that should give you the answer right away. 3 decimal places, you can truncate, you can round, I don't care. So I'm going to truncate, it's 1.470, okay? If they ask you to do units, this is the area, will be unit square. Okay, now we're going to do a whole bunch of things with the same problem, but kind of covers every single point that we talk about in the whole unit. What if this is a solid, but we're going to make them a cross-section volume? The cross sections are perpendicular to the x, are equilateral triangle. Somebody remind me, what is the formula for the equilateral triangle cross section? Root 3 over 4 s squared. What is s? Top minus bottom, right? So that's all we do. Volume equal to the same intersection from A to B. We are not evaluating this because they say, right, do not evaluate. You can put root 3 on the over 4 on the outside. S is the same as right there. Again, distribute negative or not, that's up to you. I don't want to do that. Minus 3. And then the x, don't forget square. Root 3 over 4 s square dx. You might have some multiple choice that don't have a square, and that's the one you don't want. Okay. All right. Now we're going to the volume. So every time when they say volume, revolving, rotating, whatever, I recommend you to draw a different picture. We're going to rotate this thing by the y equal -3 line. So I'm going to draw that. Rotate this way. Figure out how to give me the integral. You can do this. Wash your disk. Spit this up. Part C, your turn. And we'll do part D together. Part D is kind of hard. Yes. You have to do zoom in a little bit. Like zooming.
but you want to see this card, not that card, right? So how do you go? Yeah, this one is not enough up there, so you can change the window a little bit. The y value can be a little bit bigger than 0. See, you have C4. You can have it down there and it's going to come up there. Sometimes you just put the window. Yeah,
It's rotating over why
or you can do change the window. Yes?
it's a vertical.
You have it set up already.
Vertical side is like the top and the bottom, right?
This is that's a formula. Cross section.
So we do this minus
Yeah,
this
it's
and then this
root
minus
3 over 4x squared. X is
That's what you said. That's what you said.
I don't need so much work for this.
Linear.
Yeah.
And then small r is right.
Yeah, I don't need so much work for that.
What's smaller? Oh, that's kind of easy.
All right, this or washer, guys. Very good. Vertical or horizontal? Vertical or horizontal, guys? Vertical rotation, yes. Yeah, that's I thought that's what I said. What's the big R then? ln x minus who? How about -3?
Oh, yeah.
Yeah. Okay. So big R is natural log of x subtract -3. Are we okay? Top minus bottom. That's why it's not always -0 all the time. It's the whatever rotation. Yeah. So that's natural log of x plus 3. What is small r? Minus. So it should be just 2x. Yeah, good. 2x minus 3 subtract -3. That's just 2x. So now again, if you write r of x and an r of x like this, you can just write the notation on the FRQ. Now remember, this is distant washer. You do need pi, right? Without the pi, it's a square. It's not distant washer. Pi from again a to b. You can write big R of x. Just need a bracket though. Square subtract r of x square as long as you define them. Because again, like every time they ask you to just write, do not evaluate, this is what I'm going to do. But if they ask you to find the actual thing, you actually have to compute it on the calculator. Okay, I'm not going to find them. You're supposed to know how to type this in the calculator anyway. Now, the last one is pretty hard because the revolution is totally different. It's the exact same thing, but this time we're gonna revolve about the y-axis. So every time they have a different revolution, I'm gonna ask you to draw it again, because otherwise it's too hard to think in your head. Okay, remember this guy, we want to revolving by the y-axis. What type of revolution is this now? Horizontal spin, yeah. So we know this is horizontal. That means we need the big R of y. Is this a washer still? It's a washer. So we need a small r of y as well. Can you find those? And not only that, guys, we need this a value and this b value. We cannot use those. We need to use the y value of a, the y value of the b. How do we find that? Anybody know? Ajay, how do you find the y value of the bounds? Will you pay attention? Anybody know how to find the y values? Oh, how do I know the what? Exactly. So like x, well, x, but if I put, what is x? X are the inputs. What's the y value? The y value are the y value of both of this. They're supposed to be the same, right? So like if I do natural log of x, natural log of a, hold on, versus 2 times a by 3, it should be the same thing because that's the y value, right? So you can use that as your c and d value if you want to. Or you can just say ln a and then whatever. So I actually recommend you to figure out what C and D are, because those are the Y values. I just should write that down. D value is, what's D value? Natural log of B. Or 2B minus 3 should be the same thing. So like, you can use C and D for the Y, right? But what's the equation for the big R and the small r? And what do we need to do to find those, guys? How do we find the equations? Yeah, so, solving for those, right? So if I know y equal to natural log of x, what is x equal to? E to the y. There you go. What's the other one? We know y equal to 2x minus 3. So what is x? That's y plus 3 over 2 equal x, right? We need those two. What is a big R? Who minus who? Right minus left. So which one minus which one? The linear, this guy, right? That's a big R. The linear function minus the axis of revolution. So our big R of y should be y plus 3 over 2 minus 0. What is small r? E to the y minus 0. Yeah. Again, as long as you define this, you can use that in your integrand, in your setups. The volume is pi from C to D, big R bracket of y square minus small r of y square with a dy. I don't have room. There you go. That is a pretty hard question, but I know they are always on the test. You're going to have one like that, actually harder than this on your actual test. So we need practice. The one I'm giving you on the test is non-calculator, and you got to do all of this. So, but obviously the problem I'm giving you is easy to integrate. Okay, so next class, we're gonna do a lot of FRQ practice to make sure you understand how to do this. Then, I need you to check off at least one DP today.